Hello everyone. So in this video we will learn about two-pointer algorithm. So two-pointer algorithm is used to traverse the array and meet some specific condition, and it is used to reduce the time complexity from O of n squared to O of n basically. So it is an optimization strategy where we use basically two indices to traverse the array, and we don't use the nested loop because it take time complexity of big O of n square. So I hope you understand this. So now let's say how there are two types of two pointer technique. So first is, let's say there is an array 1 2 3 4 5. So the two pointers, we take two variable, let's say I and j. So one type of two pointer is that we move the pointers to the opposite direction. Here, like this, in the I to the right direction and j to the left direction. So this is the first type of two pointers, and there is also a second type. Let's say there is the array. Here what we do, basically we take the two pointers at the starting point only, and we move it to the same direction. Basically we move the one pointer to the same direction and to the other, let's say I to the also same direction, but to meet a specific condition. So this is also known as sliding window technique. Basically we use this in the subarray problem. So I hope you understand what is the two pointer and its type also. So now we would take a example to understand it better. So we would take an array, let's say, and the condition is that the array will be always sorted. So let's say the array is 2 7 11 and 15, and we have to find any two pairs of from the array such that their sum is equal to k. Let's say k is here 9. So you, what would be the brute force method to solve it? We would see first. So we would simply calculate all the pairs and check whether the sum is equal to 9 or not. This would be the brute force method. So what we do, we simply run two for loops. We simply run two for loops and check every pairs of element, that if array of I plus array of j is equal to k. If we get, so we will return true basically. But as we know, we are traversing the array, but we use simply two nested loops. So what would be the time complexity of this? Big O of n square. So that's why this would give a TLE. So now we would see the two pointer optimization for this question. Now let's begin. So what we do in two pointer, let's say this is the array 2 7 11 15. Now here what we do, as you know, the array is sorted. So let's say if we point the first pointer to the first index and the second pointer to the last index of the array, now what we do, we check that the sum is equal to k or not. So what is the sum? Basically sum would be 15 plus 2 17. Now here you can see 17 is basically 17 is greater than 9. Now as we know, the array is sorted, so what you can do, if you move this pointer to this direction, so what would is the sum? Sum would decrease, because as you know, the array is sorted, so in this direction the value would be decreasing. so sum would also decrease. And what would happen if we take if you plus the this pointer to here? As you know, in this direction the array is increasing order, so the sum would increase. So hence we would point this, we would add this pointer and it would come here basically. So now we would check the sum. What would come? 2 plus 11, 13. Again we would check the whether it is equal to or not. So it is not equal to, it is again greater than 9. Now it is okay to again move j pointer to here, because as we have to decrease the sum, not increasing. So in for increasing, what we do, we basically we plus the pointer I to the right direction basically. So as we came here j, so sum would become now 7 plus 2 equal to 9. Now it as we can see here, 9 is equal to the k value, so we will return true. Now let's see the code of this, how we will do this. Basically what we do, first we will take I is equal to 0 and j is equal to n minus 1 basically. Now we will run a while loop until I is less than j. Why would not equal? We will take equal because we have to find two pairs, not equal, not at the, let's say array um, is 9 basically. So and we have to find k is equal to 18. So if we take this two this same element only, then 9 to the 18. So in the question is we have to find two pairs only, so that's why we would not take equal to sign here. Now we would run the while loop and we would take first the sum basically. What is the sum? Sum would be the array of I plus array of j. Now if the sum is, we would check the condition. Now if sum is less than k, so what would happen if sum is less than k? We would basically, as we see here, if sum is less than k, we would simply plus this pointer to here I plus plus, because we need to increase the sum. So as we know, the array is sorted, if we increase the pointer to here, the sum would increase. So we would simply plus the I pointer. Now we would check the condition if sum is greater than k. So now we would simply minus the j pointer, as we have to move the j pointer here to the left direction. So we would simply minus the j pointer to the simply j to the one value. So now what would happen? The sum would decrease because the array is sorted, so in this direction is simply descending. As you can see 15, 11, so sum would simply decrease. Now the last condition is, if we get this sum is equal to k, we will simply return true. And if it didn't get any value, we would simply return false. Now we talk about the time complexity of this problem. So here you can see we simply traverse the whole array. So we didn't use any nested loop. So the time complexity would be simply big O of n. And what is the space complexity? It is as we didn't use any extra space, so big O of n or constant space. So this is the two pointer. Now we would see the code of this question where the array is sorted and understand it more better. So here you can see simply I have made a check function to check whether the pair exists or not. So this is the array 2, 7, 11, and 15, and we would take k value first, as example 9, let's say. So here we will get the pair for 2 plus 7 is equal to 9. So simply now we would see the check function. Here I have taken the two pointer I and j, you can see, and I is simply pointing to the first element of the array, and j is simply pointing to the last element of the array 15. So now we will run the while loop till we get I till the I is less than j. So uh, in the while loop we will simply check whether the sum is greater than the required value k or less than k. If it is equal, we would simply return true. What would happen if we get the sum simply greater than k? So as you know, the array is sorted. We simply do k. We would simply move the j pointer to the uh, left to the 15, so 11. So simply sum would reduce. So now you should be thinking that why we would not plus the I pointers. As you can see here, if we increase the I pointer, the sum would increase because it is in ascending order. So in the right direction, the value will always increasing. So sum would also increase. So we would simply minus the j pointer in one value simply. So now we would check if it's less than, we simply plus the I pointer as we want to increase the sum. So, and if we got, we will return true. So this is all about two pointer. So as you see here, we simply check, and if we got the value equal to true, we would simply see out we have got the found pairs, and if we get false, so no pair exists simply. Now we check for the value k value equal to 9. So as you can see, we have got the output found pairs. So as you can see here exists 2 plus 7 9. So it would return found pair. So what would happen if we pass the value 20? Simply you can see no pair exists. As you can see, we didn't get any pairs whose sum is 20 in the array. So simply it would output no pair exists. Now you can see the time complexity is simply big O of n because we are simply traversing the array one time only. So the worst time complexity would simply big O of n. And since we are not using any extra space, so space complexity would be big O of 1. So now on this note, I would end this video. I hope you understand the topic two pointer algorithm technique.